Okay, so we're going to prove by contradiction that no integers y and z exist for which 24y plus 12z is equal to 1. So there's no integers apparently that exist where 24 times that integer plus 12 times that other integer is equal to 1. So we're going to prove this by contradiction. Okay, so proof by contradiction. Okay, so we're going to assume there are uh, integers y and z for which 24y plus 12z is equal to 1. So we're going to assume that there are. Okay, so I know that both of these, I can factor out a 12 from both of these. So I know that 12 times 2y plus z is equal to 1, right? And then using some algebra, I can write this. I can write 2y plus z is equal to 1 over 12, right? So notice here, I have y and z are integers, right? And 2 times an integer is an integer. So I have this is an integer, right? I have this is an integer. So, and the sum of two integers is, of course, an integer, right? But look, I have an integer is equal to a rational number, right? This is a rational number, not an integer, right? This is not an integer. Because remember, a rational number is defined as an integer divided by an integer. So notice when I assumed that there are integers y and z for which 24y plus 12z is equal to 1, I got to the contradiction that an integer is equal to a non-integer. And this is just blatantly a contradiction. Okay. Thus, the original statement must be true. Thus, there does not exist integers y and z for which 24y plus 12z is equal to 1. So that is an example of how a proof by contradiction sort of works. Okay.